All right, everyone. So we are now going to get into our diverging mirrors. Right? But first off, before we get into that, I just want to do a quick little refresher on our concepts involving our converging mirrors, as our diverging mirrors are going to have very similar properties. So again, when we're looking at our converging mirrors, right, we saw that there were kind of two specific rules that we were going to follow. Okay, rule number one was that any incident ray traveling parallel to our principal axis will reflect through the focal point. And then our second one was that any ray, any incident ray, traveling through the focal point will reflect parallel to the principal axis. Right, so just kind of a quick little refresher here. Okay, obviously F2 here, this is our center of curvature. And F is going to be our focal point. So if we are going through any individual problem and we're trying to locate an object, remember that we are taking our ruler, right? Your first line is always going to go from wherever that object might be, and you're going to try and make that as parallel as possible to the individual principal axis. Now we know based off of our rules, that was not good. Based off of our rules, if that is traveling parallel to this principal axis, their reflected ray is then going to pass directly through the focal point. So that would be our incident ray, and that would be our reflected ray. And then we also know that if we do have any incident ray that travels through the focal point and contacts the mirror, it is then going to reflect parallel to the principal axis. And these are really the two concepts that we used in our ray diagrams for our converging mirrors or our concave mirrors. And the process is going to be quite similar for our diverging mirrors. Right? But when we go to look at diverging mirrors, and I know that I did kind of mention this the other day, when we start to compare our diverging mirrors to our converging mirrors, we start to get into a little bit of a complicated spot. Because if I do take, let's say we go back to rule one here, any incident ray traveling parallel to the principal axis, well, we know just by simply looking at this mirror, if I were to make a parallel line to the principal axis, right, let's just say my incident ray is coming in parallel to the principal axis at this point here. So this is my incident ray. We know that at this point, if I were to have, let's say, my focal point here and my center of curvature here, given the kind of angle that this mirror is on, there is no possible way that that ray is going to reflect down through that focal point. It's just not possible. So instead, what we will actually notice with these mirrors is that we're going to have to use what we call a virtual focal point. And that virtual focal point is actually going to be beyond the mirror itself, right? Or it might appear to be inside of that mirror. And what's going to happen here is we are going to reflect that ray off of the surface of the mirror in the direction that seems to be, that it appears to be going, right? So here, you will notice that that individual ray is going to reflect off of that mirror, right? But interestingly enough, when it does reflect in that direction, if you look backwards, and we always draw these with dotted lines, you will notice that is going to follow still from, or follow off of the mirror. So this is my reflected ray. But you will notice that this is going to follow through, back through the virtual focal point, right? And we did this in class yesterday using the ray box and kind of drawing it out on a piece of paper. And that really doesn't matter where I do it. Even if I do it way down here at the bottom of the diagram, right, you will see that if this incident ray is coming in, right, you're going to see that the reflected ray is going to come off of that mirror in the direction opposite to the virtual focal point, right? So what we see here is that we are starting to see these dotted lines again behind the mirror. And these were very similar to what we saw in our plane mirrors when we were doing those simple reflections. So again, this is an incident ray. And this is my reflected ray. So even though we aren't necessarily directly reflecting these individual rays through the focal point itself, right, if you were to reverse those or have those going into the mirror, they would still intercept with that virtual focal point, right? Same thing goes for rule 2. If we go back to rule 2, where it says any incident ray traveling through the focal point will reflect parallel to the principal axis, that is going to remain true as well. Right, we are going to look here. We saw that when we draw that through, it's going to reflect parallel. We're going to do that exact same thing, but this time, instead of going through and having that reflect on this side of the mirror, we're going to have it so it's passing through the virtual focal point beyond the mirror. So let's just say I had a random line, or sorry, incident ray coming in at this direction through the mirror, right? That would continue beyond the mirror itself. And then what would happen is the reflected ray would then reflect parallel to the principal axis. So really, nothing is changing here. But what you will see is we're just kind of working on opposite sides of the mirror again. So this is an incident ray. And this here is my reflected ray. So when we actually really break down these types of problems, they really are no different from our original problems that we did with our concave mirrors. The only thing that we're going to be doing here is we're going to be extending our incident rays and our reflected rays back beyond the actual mirror itself in order to generate what we call our virtual image. Because now, as you've seen in parking garages and anywhere that has these diverging mirrors, you're going to see that these images always appear to be very small and very sunken in beyond the surface of the mirror. So we'll get into a problem here just to kind of start seeing how these things are actually going to work. So our problems for diverging mirrors are going to look very similar to our problems in converging mirrors. The only really difference is going to be is that you're going to see now the rounded side of that mirror facing your object, and you're going to notice that F and F2, right, which is your focal point and your center of curvature, are now going to be located on the virtual or the opposite side of the mirror. So remember, this is our virtual side of the mirror. So we are going to go through the exact same process as we saw. I'll use the exact same color code as well. So starting off, no different from what we did in our other examples, we are going to take our ruler and we are going to construct a line that is running parallel to the principal axis. I'm just going to have one here, try and get it as best as possible parallel, right, running from the point of the arrow again back to that mirror. Okay, so again, this here is our incident ray. And then with that incident ray, right, we are going to see that when it is reflected off of the mirror, it is going to travel away, or it's going to diverge away from the point or the object. However, the angle that it is going to divert away from that mirror is going to be an angle in relation to the focal point. So really, what's going to happen here is that is going to extend beyond, and we are going to put some dotted lines back through my focal point. Okay? So here, we can see that the reflected ray is here. It is diverging away from that object. right? So this is my reflected ray. Right, and we are always going to make sure that we have those dotted lines if they are beyond the backside of the mirror. Okay, now the next thing that you are going to see, exact same thing as we saw last time, is now we are going to start by having our second incident ray traveling directly to the focal point. However, this is not necessarily going to be something that is able to happen, as it won't be able to actually physically pass through that mirror. But we're going to go through with that anyways. So I will take my line, starting at the point of the object, and I'm going to draw my incident ray traveling towards the mirror as if it were to go into that focal point. Right? Now, once we get to this mirror, we know that that is no longer going to be able to pass through that mirror. So instead, it is going to be reflected off of the mirror, again, parallel to the principal axis. This is going to reflect parallel to the principal axis in this direction. So this is my reflected ray. And this here, I won't write incident ray, but that is our incident ray. Now, in order to figure out where our virtual object is going to be, we are going to take that reflected ray that is running parallel to the principal axis, and we are going to extend it beyond the backside of the mirror using our dotted lines. And what you will notice here is that those two lines are going to intercept at a very specific point. Now that point there, just like when we saw in our converging lenses, is going to be the location where your image is going to be. So I can draw my little arrow here, and that is going to be the location of this image. Now, knowing that this is on now the back side or the opposite side of the mirror, this here is going to be what we call a virtual image. And what you will notice is, contrary to what we saw in our converging lenses, this now is an upright image as well. So it is upright, and it is much smaller than our original image. Sorry, original object. Right, and that is essentially how we create a ray diagram for a diverging mirror. So we'll do one more here, and I've just kind of slightly moved the original object backwards, away or further away from the mirror, just to see how that kind of influences the individual image that is being created on the virtual side of the mirror. In addition to moving it away, I've also made the image a little bit larger than it was in our first example. So again, going back to my red pen, this is always going to represent where we are using our parallel line. So again, starting with our parallel line running parallel, our line running parallel to the principal axis, right? Again, we are going to draw that line in until it contacts the mirror. Now we know, based off of our observations in class with our ray boxes, that that is going to diverge away from the object itself in this direction. However, if you look backwards and trace that back, that is still going to pass through our focal point or our virtual focal point on the opposite side of the mirror. So again, here is my incident ray, this is my reflected ray. Now our second option that we always go through, we are going to take a line drawing from the top of the arrow as if it were to go all the way through the virtual focal point. Now we know that light cannot pass through these mirrors, it is being reflected. However, this is going to show how we are creating our virtual object. So that's going to come into the mirror. We know, given our rules, that that is now going to reflect away from the mirror, parallel to the principal axis, just as we've seen in every other example before. So I'm going to take my line, and I'm going to draw that reflecting away parallel to that principal axis. And then all you need to do is extend that individual line using our dotted lines now beyond the mirror itself. And we are going to see once again that we have an upright image that is virtual showing up in this mirror. So again, it is a virtual image which is upright, smaller, and beyond the mirror. Okay, so we're starting to see that very, very similar trends involving each one of these scenarios. Okay, we have both situations where virtual image is upright, smaller, and behind the mirror itself, right? Even though the original location of the object was a little bit different from one another. So if we get to our SALT table that we saw before, right? We ask for size, attitude, location, and type, right? And each one of these, our diverging mirrors are going to be quite simple because they are pretty much the exact same. So as we noticed in each one of our examples before, right? The size of each one of those arrows is going to be quite a bit smaller. So for our diverging mirrors, this is going to be irrelevant of where the original location of the object is. The size is always going to be smaller than the original object. So I'll just write than the object. Right, and this is something that you're going to notice in actual diverging mirrors. Second one, when we are talking about our attitude of these individual diagrams, right, what you are going to notice is that the attitude we have, again, the choice, is it going to be upright or is it going to be inverted? And again, we can see in these examples that it is always going to be upright. Okay, so the attitude is always upright or in the same orientation as the original object. If the object were to be upside down in your first example, it would remain upside down on the opposite side of the mirror. The location is always going to be behind the mirror. And that is kind of self-explanatory that then, because it is behind the mirror, it is obviously going to be a virtual image. Right, and these things should make sense. If you've ever seen a security mirror in a store or even in some sort of a parking garage, you're always going to notice that the objects in those mirrors are going to appear to be quite small. However, they're not going to be flipped upside down or flipped from left to right. Right, you are always going to notice that they are upright or in the same orientation that they are in the world around you. However, it's always going to appear that those things are inside of the mirror, therefore making them a virtual image. Okay, so hopefully this helps with trying to complete our ray diagrams with our diverging mirrors. Really, in understanding our converging mirrors, this should be quite self-explanatory. So please use this video to help you get through your problems in your assignment today. And if you have any questions, send me an email and let me know.